Hey everyone, and welcome. Today we're diving headfirst into a truly radical new theory, one that takes on one of the biggest mysteries in all of science. Why do the laws that run the galaxies and the laws that run atoms just refuse to get along? Well, it turns out a single equation might just be the answer we've been looking for.
So let's get right into it. The central problem, the big elephant in the room for physicists, is that modern physics is, to be blunt, fundamentally broken. The two absolute cornerstones of how we see the universe, well, they just don't speak the same language. It's this great, unsolved puzzle that we're going to unpack today.
And this is what we call physics' great divide. You've got one set of rules for the incredibly big, the cosmos, and a totally different, clashing set of rules for the incredibly small, the atom.
On one side, you have Einstein's general relativity. It's beautiful, it's elegant, and it describes this smooth, flowing universe where gravity is just the gentle curving of space-time. It works perfectly for planets, galaxies, black holes, you name it. But then, on the other side, you've got quantum mechanics, and it describes a world that's, well, it's grainy, it's pixelated, it's all about probabilities and weird quantum leaps. One is smooth, the other is chunky, and when you try to make them work together mathematically, they just fall apart.
So how in the world do you build a bridge across a gap that wide? Well, this new theory has a wild suggestion. It says maybe we haven't just been using the wrong math. Maybe we've been missing an entire dimension this whole time. What if reality itself has a zoom function?
The main idea here is that scale isn't just the concept we use. It's a real, physical place you can go. Just think about it like a cosmic elevator. When you hit the down button, you're not moving through space, you're moving through scale. You're zooming from the level of galaxies, right past the stars, past our planet, and all the way down into the bizarre world of atoms.
The theory even gives this new coordinate a name, u. And you got to get this is the crucial part. It's not just some variable in an equation, it's defined as an active coordinate, a real direction. Moving along u is what physically links the smooth reality of the cosmos to the grainy, strange reality of the quantum realm.
Okay, so if we have this new dimension, what's everything actually made of? Well, the theory introduces something called the H cell. You can think of it as the fundamental pixel of our universe. In this new picture, every particle and field we know, electrons, photons, the whole shebang, is really just a zoomed-out, blurry view of different arrangements of these basic geometric building blocks.
And that, of course, brings us to the star of the show. Because if this new dimension of scale is real, there has to be a master equation that runs it all. So let's meet the quantum geometric scaling equation, or QGSE for short.
And there it is. Whoa. Okay, don't let the symbols freak you out. We're not going to do a deep dive into the math. We're going to break down what it all means. Because the claim here is that the single line of text is the master recipe for the entire universe, from the Big Bang all the way to us sitting here right now.
So, how does it pull this off? Well, it's actually a pretty clever tweak on an equation we already love. First, you start with the heart of Einstein's general relativity. That's the g mu v bit. It's the familiar part. Then you add a totally new ingredient, the h mu v term. Think of this as a kind of stress or pressure that's coming from the very geometry of the scale dimension itself. And finally, the energy part on the right side is windowed. That just means the equation only cares about the energy that's happening at the specific zoom level you're looking at.
All right, so we've got this new master equation. Here's where it gets really cool. This one equation is like a chameleon. You put it in different situations, and it completely transforms to speak the language of all three major pillars of physics.
Seriously, this slide right here, this is the whole ballgame. This is the heart of the entire theory. Just look at this. If you're in a situation where scale is locked and gravity is weak, like planets orbiting the sun, the QGSE naturally simplifies and becomes Newton's law of gravity. Bam! If you're looking at things from one single sharp scale, it perfectly becomes Einstein's field equations. And here's the jaw-dropper. When you have multiple scales interacting and moving around, it transforms into Schrödinger's equation, the absolute bedrock of quantum mechanics. It's just one equation, three completely different realities.
That right there is the breathtaking elegance of this whole idea. It's not three separate conflicting rulebooks for the universe. It's one fundamental law that just wears different masks depending on where you're standing in the dimension of scale.
But look, a beautiful idea is one thing. To be actual science, it has to make predictions. You have to be able to go out and test it, and, more importantly, you have to be able to prove it wrong. A great theory is only great if it's falsifiable.
So how could we possibly test for a hidden dimension? Well, the theory gives us a huge clue. It makes a very clear prediction.
If this dimension of scale is real, then things that exist on different rungs of the scale ladder should be able to, ever so slightly, talk to each other.
And this leads to a really clever experiment. Here's the plan. First, you build a set of tiny little resonators. You can picture them as microscopic tuning forks. Now, here's the key. You build them on a geometric ladder, so each one is a precise ratio bigger than the last. This puts them on neighboring rungs of the scale dimension. Then, you measure their vibrations with unbelievable precision, and you look for tiny systematic errors, tiny differences from what our current physics says should be happening.
So what kind of error are we looking for? The theory predicts a very specific signal called sideband splitting. The best analogy is musical. It would be like listening to a perfect, pure note from a tuning fork and suddenly hearing these extra, faint little harmony notes that have no business being there. Finding those structured, predictable ghost notes in the universe's harmony would be incredible proof that these rungs of scale are real.
And this isn't a one-trick pony either. The theory predicts other possible signs we could look for, things like structured, non-random noise in supersensitive laser experiments. Or, get this, maybe even finding that so-called fundamental constants, like the gravitational constant g, have slightly different values depending on the scale you measure them at.
So let's zoom out for a second here. What would it actually mean for physics, for our whole map of reality, if this thing turns out to be right?
Well, for starters, all that legendary quantum weirdness, a particle being in two places at once, spooky action at a distance, it might not actually be weird at all. This theory suggests that all those bizarre effects are just the natural result of geometry, the geometry of objects moving and interacting through a hidden fifth dimension that we just couldn't see before. It's not magic, it's just a map we were missing.
And this dedication to real science is right at the core of the whole project. The author, Nader K. Hijazi, says it perfectly in the paper. The program will stand or fall on tests. The most important point is that the evidence they're looking for isn't just random static. It's a specific, structured signal. It's a clear target to aim for.
Which leaves us with this one last, absolutely tantalizing thought. For centuries, we have mapped our reality in 3 dimensions of space and 1 of time. We thought that was the whole map. This theory suggests there's been another direction to travel in all along, hidden right in front of us. So the question becomes, if scale really is a physical place you can go, what other secrets is reality hiding, just waiting for us, right beyond our current view?